what is observability made of? In the last module, we talked about the pillars of observability. Here we'll look under the hood a little more. So this diagram is, you're going to see repeated in different forms throughout this module, and we'll explain how different things work across the observability architecture. So at the front end, you've got a human using a user interface, which may be a dashboard or other forms of a user interface, which is using data from some storage. It could be a data lake or some other storage for all the information that's available to the user. Behind the scenes, there's some processing going on. In particular, there's telemetry to gather information from various points in applications. So each application, each of these blue boxes represent an application. And together with the application, there are libraries potentially for collecting data for the tracing and logs and metrics, as well as agents, which could be agents that are, working alongside an application within the same server, for example, or container. And you may have multiple applications where you've got one application as the root and others that are child spans. The red boxes really are the application, I guess, and what's being observed is the total package. These supports from agents and libraries. So from the user interface point of view, generally speaking, you've got several things that are required. How well is the system working? And when things go wrong, what is wrong? For example, why is it working slowly? So you hopefully can get that information back to the user. At the back end, at least starting from the storage, you need to know, where to get that the data for the user interface. And this could be in the form of metrics, logs, various events that are part of traces. The processing is really trying to get data from the source applications. Typically, some components gather the source and process it prior to storage so that you can have some normalized data in your storage, standardizing fields, maybe samples of data, sending one or more, to one or more backends. The agent source are, again, the applications and agents. So the agents tend to reside on each server together with the application to record metrics from the operating system or whatever the application is as well. Gather logs from the local files and collect events and traces from the local applications. The application source itself could emit telemetry using different libraries. So generally speaking, the libraries are embedded within the application, and these could be automatically instrumented libraries that could work from Bootstrap telemetry to help automate the insertion of libraries. APIs may be used for adding custom information with lines of code. Between the applications, you've got trace context propagation. So network calls could propagate the trace context. The W3C standard publishes the standard for HTTP. The telemetry libraries add headers when things are being sent, and they read headers when they're receiving. So we'll go through a more deep dive on the different components. So you have, in general, libraries, again, on co-resident with the application, APIs to work with applications, agents that we may work alongside of applications, a collection for processing, and the processing itself to normalize data. You may have different protocols for transmission, storage, which is where you're putting all the data before you consume it through a user interface. Again, this may be, distributed across different networks. Typically, the production network will have your running applications if it's deployed code, and there's a network or administration or an SRE network, for example, where you're working with the data and the displays of the data. This is just a summary of what we just said. So there's basically three types of components: libraries, APIs, agents, and collection and processing back at the application side, storage and UI at the user side, and then in between, transmission protocols and formats. All right, let's go a little bit deeper dive on OpenTelemetry. Short form is OTAL, a project for open source community-generated observability standards. So the Cloud Native Computing Organization, CNCF, supports a number of different open source projects. So OpenTelemetry is one of those. The biggest project actually is Kubernetes. The second one is OpenTelemetry. The transmission format and protocol, again, is OTLP, OpenTelemetry Protocol. The community, open source community, governs the specification. You can use gRPC or HTTP to connect to it and transmit through binary protobufs, or if you must, JSON is kind of a secondary option. Using OTLP for tracing, the first format that's been stabilized was for tracing. The format needed standardization the most, merges two former standards, which were called Open Census and Open Tracing. And that's been stable, version 1, and stabilized in February 2021. It supports a resource, what sent these spans. The service name could be, like, for example, checkout service. The scope is what instrumentation emitted those spans, for example, the name. OpenTelemetry instrumentation ATP would be an example of scope. Spans, a span of spans, so you have multiple spans involved in a complete trace. Each span has trace ID, span ID, parent span ID, the name, span, start time, end time, various attributes, and you can have more data as well as relevant for the particular span. As far as metrics are concerned, the API, there's an API standard, version 1.8 of the OTel spec. It was stabilized in November 2021. It's compatible with both StatsD and Prometheus tools. There's an example on the right side. Don't really need to memorize that, but it gives you an idea what it actually looks like. So you have a message defining a trace, defining a metric, string name, string description, string unit, and at least one of these data items. Logs, the protocol is currently stable as of 2023. There's more consideration of legacy in the standard than previous versions. It includes trace ID, span ID for linking the traces. So again, there's an example on the right side. You don't really need to memorize it, but you can see it's composed of message log record with some attributes, fixed 64 time Unix nano, severity number, string severity, what version of protocols are being used, repeated OpenTelemetry protocol version 1, key value, and different attributes.